Sodium is a chemical element with the symbol Na. It sits in group 1 of the periodic table, among the alkali metals. It has an atomic number of 11. Sodium is a soft, silvery metal. It is highly reactive, especially with water and acids. Although it is very reactive, sodium is never found freely in nature. Instead, it is found combined in compounds. Its compounds have been used for thousands of years. The discovery of sodium came relatively late in history. The element was first isolated in 1807 by Sir Humphrey Davy. Davy used an electric current to separate sodium from molten sodium hydroxide. This was part of his groundbreaking work on alkali and alkaline earth metals. Earlier, sodium compounds had been known and used. Sodium carbonate, also known as soda ash, was used by ancient civilizations. Egyptians and Mesopotamians used it in soap making and glass production. Sodium is a soft metal that can be cut easily with a knife. It has a bright silvery appearance when freshly cut. However, it oxidizes quickly in air. The surface becomes dull and gray due to the formation of sodium oxide. Sodium is much lighter than many metals. Its density is about 1/3 that of water. This means sodium can float on water. It has a low melting point of around 98 degrees Celsius, which is unusually low for a metal. Chemically, sodium is extremely reactive. It reacts vigorously with water to form sodium hydroxide and hydrogen gas. The reaction releases heat and can be explosive under the right conditions. Sodium also reacts with many other elements, especially halogens. For example, it combines with chlorine to form common table salt. Sodium tends to lose one electron in reactions. This forms a positively charged ion, Na+, which is highly soluble in water. Sodium has many interesting properties. It conducts electricity very well in its molten state. It forms alloys with some other metals, which can have special industrial uses. Its compounds are widely used in everyday life. Sodium ions are essential in the human body. They help regulate fluids and nerve impulses. Without sodium, life as we know it would be impossible. Sodium also appears in surprising ways in nature. The ocean contains vast amounts of dissolved sodium salts. Salt lakes, like the Great Salt Lake in Utah, are rich in sodium compounds. Some desert soils also contain sodium-rich minerals. Even some minerals deep in the Earth's crust are important sources of sodium for industry. The global distribution of sodium shows how abundant and essential it is. Historically, sodium compounds were more valuable than sodium metal itself. Before its isolation, soda ash and saltpeter were highly sought after. These compounds were critical in glass making, soap production, and preservation. Salt, a sodium compound, was so valuable it was sometimes used as currency. This illustrates the importance of sodium long before chemists fully understood it. Pure sodium metal must be stored carefully. It is often kept under oil to prevent reactions with air or moisture. Even small amounts of water can trigger vigorous reactions. Because of this, sodium metal is rarely handled outside laboratories. Yet, despite its reactivity, sodium has a safe and significant role in chemistry and industry. Sodium is very soft. Its softness is one reason it is used to demonstrate basic metal properties in educational videos. It also illustrates trends among the alkali metals. Like lithium, potassium, and others in the group, sodium reacts strongly with water. Comparing these metals shows how reactivity increases down the group. Sodium occupies a key position in helping us understand chemical patterns. The color of sodium compounds is often striking. Sodium salts can appear white, but some compounds show vivid colors. For instance, sodium vapor emits a bright yellow light when heated. This property is used in street lamps and signs. The yellow glow is so characteristic that it can be seen from great distances. It is one of the most recognizable features of sodium in modern life. Sodium is an essential nutrient. In the human body, it is primarily found as sodium ions in blood and other fluids. Sodium regulates blood pressure and fluid balance. It is crucial for nerve function, allowing electrical signals to pass through nerves. Sodium ions are also involved in muscle contraction. Without sodium, our bodies could not perform basic functions. Sodium compounds are widely used in industry. Sodium hydroxide, known as caustic soda, is used to make soap and paper. Sodium carbonate is a key ingredient in glass manufacturing. Sodium bicarbonate, or baking soda, has many household uses. Sodium chloride, table salt, is vital in food preparation. Industrial applications of sodium compounds are extensive and diverse. One of the most fascinating aspects of sodium is its reactivity. When sodium metal contacts water, it produces a dramatic reaction. Hydrogen gas is released, and the sodium rapidly disappears as it forms sodium hydroxide. This reaction demonstrates fundamental chemistry principles: electron transfer, chemical bonds, and energy release. It is a vivid illustration of the power of reactive metals. Sodium also reacts with acids to release hydrogen gas. For example, with hydrochloric acid, sodium forms salt and hydrogen. These reactions are important in laboratory demonstrations. They show how metals interact with acids, a fundamental chemical concept. Sodium's ability to react with both water and acids makes it a model element for study. Sodium compounds are also important in medicine. Saline solutions contain sodium chloride and are used to hydrate patients. Some sodium salts are used as antacids or laxatives. Sodium bicarbonate helps neutralize excess stomach acid. The medicinal role of sodium compounds shows how chemistry directly impacts human health. Sodium plays a role in modern technology. Sodium vapor lamps are common in street lighting. These lamps are energy efficient and have a long lifespan. Sodium is also being studied for use in batteries. Sodium-ion batteries are an alternative to lithium-ion systems. They could provide more sustainable energy storage in the future. In the natural environment, sodium cycles between the land, water, and atmosphere. Rivers carry sodium compounds to the ocean. Evaporation concentrates salts in lakes and seas. This global movement of sodium is part of Earth's geochemical processes. Sodium is not only important in industry, but also in understanding natural cycles. Sodium has a unique position among metals. It is highly reactive, yet essential for life. Its compounds are found everywhere, from oceans to our kitchens. Sodium's reactivity has taught chemists about chemical bonds and electron transfer. Its abundance and utility make it one of the most important elements in daily life. Despite being reactive, sodium is manageable in controlled conditions. This has allowed chemists to study it safely. It serves as an educational tool to demonstrate principles of chemistry. Observing sodium's behavior helps students understand the periodic table, chemical reactivity, and electron behavior. Sodium compounds have also played a role in art and culture. Glass made from sodium carbonate has been used for centuries. Salt has shaped economies, influenced wars, and inspired literature. These cultural connections show that sodium is not only a scientific element, but also a part of human history. One surprising fact is that sodium metal can be stored under inert oils to prevent reactions. This allows it to be transported safely. It also highlights how chemists can control highly reactive elements. Understanding storage and handling is an essential part of working with sodium. Sodium is light and silvery. It can float on water. Its low melting point means it can be cut at room temperature. These physical properties make it visually interesting. Observing these traits can help students connect abstract concepts with real-world observations. Sodium's role in food is well known. Table salt is sodium chloride. It preserves food and enhances flavor. Sodium is also present in many processed foods. Awareness of sodium intake is important for health. This connection shows that chemistry is not just theoretical, it affects our daily lives. Sodium compounds are versatile in chemistry. Sodium hydroxide is used to adjust pH in solutions. Sodium carbonate is a cleaning agent. Sodium bicarbonate is used in cooking, cleaning, and medicine. Each compound demonstrates different chemical principles. Together, they show the wide-reaching applications of sodium. Sodium reacts with halogens to form salts. Sodium chloride is the most familiar. Sodium fluoride is used in toothpaste. Sodium bromide has industrial uses. These reactions are predictable and consistent, which makes sodium a model element for learning about chemical bonding. Sodium's electron configuration is simple. It has one electron in its outer shell. This makes it highly reactive. Sodium tends to lose this electron to form a stable ion. This fundamental behavior is the basis of its chemistry. Understanding this helps explain many of sodium's reactions and properties. Sodium's abundance makes it easy to obtain. It is present in seawater, salt deposits, and some minerals. Extraction of sodium compounds is relatively straightforward. This availability supports its widespread use in industry and daily life. Sodium is truly a global element. In education, sodium demonstrates several key chemical concepts. Its reactivity with water shows exothermic reactions. Its tendency to form ions illustrates electron transfer. Its compounds show solubility and chemical diversity. These features make sodium a favorite element for teaching chemistry. Modern research continues to explore sodium. Sodium-ion batteries could reduce reliance on lithium. Sodium compounds are studied for environmental applications. Sodium-based chemicals may improve industrial efficiency. The potential for innovation with sodium remains significant. In conclusion, sodium is a remarkable element. It is soft, reactive, and essential for life. Its compounds touch nearly every aspect of human activity, from medicine to industry to daily nutrition. Sodium's history, properties, and uses illustrate the depth of chemistry. Observing and understanding sodium enriches our knowledge of the natural world. Sodium reminds us that even highly reactive elements can be essential, versatile, and impactful. It is a small metal with a big presence, both scientifically and culturally. Its role in chemistry, industry, and biology underscores the importance of understanding the elements that make up our world. Sodium is a true example of the power and utility of the periodic table.